So you can follow along. So the first question. An experiment was conducted where 16 10-month-old babies observed two toys, one behaving nicely and the other one behaving meanly. The amount of time spent watching each toy was observed. The difference in the time spent watching the mean toy versus the kind toy was normally distributed, so that's good because my n wasn't big enough otherwise, so we needed a normal set, with a mean of 1.1 seconds and standard deviation of 1.75 seconds. So part A, the null and alternative hypothesis. Is this matched pairs data or not? Let's see. You had 16 babies, but what did they do with each baby? They watched both toys, and so they compared. How long did the baby watch this toy versus how long that same baby watched the other toy? So is this matched pairs? Yeah. Yes, because for each baby, you have 2 times. I didn't just say, I'm going to take 16 babies and put them in this room with the nice toy, and then a different 16 babies in the room with the mean toy, and compare them. It was one baby observed both things. So this is matched pairs data. So we'd be talking about the mean of the difference. Okay, we want to see if they spend more time looking at the mean one. All right, so let's say we're just going to assume this difference is going to be the mean toy minus the nice toy. So if they spend more time looking at the mean one, then the mean of the difference would be greater than 0.
Wait, how did you know that thing?
I didn't really, a lot of times I would give you tables and we would do it that way. I didn't really specify, so that's why I just kind of said this is how we're going to do it. All right, let's test this. So we go to our calculator. What test am I going to do? Do we have 2 samples or 1 sample? One, if we're looking at the difference, we're only looking at the 1. So we're just going to go to the regular t-test. Am I basing off data or stats? Stats. The mean of the null hypothesis is 0. X bar, what is the mean of my sample? 1.14. Standard deviation is 1.75. My n, 16. If you went to the wrong test, you would know. If you went to the 2 sample t-test, then all of a sudden it's going to ask you for the mean of the first group and the mean of the second group, and you would realize I only gave you one of those. So you would know to go back and do the other one on the calculator. All right, we were testing greater than, so calculate. So we get a t of 2.6057. Probability is 0.0099. All right, compare that to alpha. We only reject if our p is less than alpha. So what would we do here? Reject. This probability is smaller than alpha. Is that okay for everybody? Let's look at some more. So it is a common belief that SUVs are safer than cars. The table shows the damage in dollars to each after they were involved in a crash together. Suppose the data is approximately normal with no outliers. So is this matched pairs or not? Yes, because they were in an accident together. So what's my null hypothesis? The mean of the difference equals 0. If it's matched pairs, we talk about the difference. Then the alternative would be, we want to see if the repair cost for the car is higher, so that means the mean of the difference if the car is higher, SUV minus car, would that be less than 0? Okay, so now when you do this on the calculator, so what do we do? Yeah, first we need to put our data in. So we're going to put the SUV in L1 and the car in L2. And since I want to look at the difference, you need L3 to be the first minus the second. And what test am I going to do? Stat test number 2, just a regular t-test. I'm basing it on data or stats? Data. Mean of the null is 0. What list do we need to use? L3. Frequency 1. We're testing less than 0. So we get a t of negative 2.6855. Probability 0.0181. So what does that tell me? Reject. My alpha is 0.02, so this is less than alpha. We reject the null hypothesis. We have enough evidence to conclude that the damage to the car was higher. Yes? You're welcome. Other questions? Okay. Let's do this question. Researchers wanted to determine whether reaction time in seconds differs between males and females. The results follow a normal distribution and are shown below. Test whether there is a difference in the reaction time between the males and females at the alpha equals 0.05 level. Make sure to include the hypothesis in the conclusion. All right, is this matched pairs or not? No. There's no, I didn't give you any information about any relationship between the two. I didn't say, okay, I took a male and a female and I threw something at both of them at the same time and saw who responded faster. There's no reason to believe these are connected. We also can check, do we even have the same number of points for both? No, so it's impossible to be matched pairs. What would be my null hypothesis then? We just assume the mean of the first is equal to the mean of the second. The alternative, I want to see if there is a difference. So what would that be? All right. So you need to enter these into your calculator. Put your females in list 1 and your males in list 2. What test do we do this time? 2 sample T test. So that is number 4. We're going to base it off data. List 1 is L1, list 2 is L2. Frequencies are all 1. Null hypothesis not equal to. So T is 0.6194. P 0.5403. Alpha this time was 0.05, so my P is greater than alpha, so what does that mean? Fail to reject. There is not enough evidence to conclude there is a difference in reaction time between our males and females. What if I asked you to build a confidence interval? Let's say I asked for a 95% confidence interval. What would we do? Okay, if we just had one sample, then we would go to number 8, the T interval. Because we have 2 independent samples, we have to go to 0, the 2 sample T interval. List 1 is L1, list 2 L2, frequencies are 1, confidence level is 0.95, pooled is no, calculate, we get negative 0.0601 to 0.112. So confidence intervals and everything we can do on a calculator. Essentially everything from chapter 11. I showed you how to do it by hand, but we ultimately did them on the calculator because we had to put the data in there anyway, so it's just more efficient. Questions there? Okay. So game plan. Today, what is today? Tuesday? I'm going to give you a chapter 11 review handout, just a few problems to help practice what we just reviewed there. Tomorrow I'm going to give you a study guide for Unit 5, and we will have a work day. Thursday, we will discuss the study guide, and Friday we will go ahead and do the test over chapters 10 and 11. I think it'll be more beneficial to us to go ahead and do this test Friday versus waiting until next week. If that's okay with everybody?
So we're not doing that.
Well,